ready.
Yeah, I think we go ahead and start.
Okay, cool, great, thank you. So good morning, good afternoon, ladies and gentlemen. On behalf of the CBD Secretariat, I would like to thank all of you for joining us today for this webinar, which will provide an update from members of the scientific community on a recent analysis of the interlinkages across the post-2020 global biodiversity framework. Note that this webinar is part of a series of webinars which will occur in the lead up to the resumed sessions of the Working Group 2020, SBI and SBSTA, as mentioned in the notification 2021-085. The resumed meetings are now scheduled to take place on 13th to 9th of March 2022 in Geneva. A list of the complete set of webinars which are being conducted can be found on the web link and as shown on the screen. And the link ends with pre-Geneva-2022-webinars. This webinar is presenting an analysis led by Biodiscovery and GeoBon, which involved more than 50 scientists from around the world. The analysis being presented is available in the form of an information document for the Working Group 2023, Part 2, as document CBD/Working Group 2020/03-INF11. The document is also available as a SBSTA document INF31. This paper represents the independent views of the scientists involved. However, since the time of the convention's establishment, the importance of science for decision-making under the convention has been well recognized by parties. This includes through the establishment of a dedicated body, the Subsidiary Body on Scientific, Technical and Technological Advice, SBSTA, which is responsible for scientific advice related to the state of the world's biodiversity, solutions, and identifying emerging and cross-cutting issues. The process for developing the post-2020 global biodiversity framework, including the current first draft, as well as the zero draft, have included an assessment of scientific information at its core. The Global Biodiversity Outlook 5 and the IPBES Global Assessment, as well as the recently released IPBES IPCC report on climate change and biodiversity, and the WEF Global Risk Report, all have similar messages in terms of the need for urgent action on biodiversity, the importance of addressing climate and biodiversity risks together, and the need for transformative change in order to tackle the drivers of biodiversity loss. This report by the scientific community fills a gap in terms of the available science by providing an analysis of specific scenarios and interlinkages between the draft goals and targets of the post-2020 global biodiversity framework. I do not want to take up too much of your time, as I would like to make sure that we have time to hear from our speakers and to have questions and answers. Therefore, I would like to welcome you to this webinar and hand over to the SBSTA chair for some opening remarks. Thank you.
Thank you very much, Jati. Welcome, colleagues. I am pleased to be invited to give some opening remarks on this webinar organized by GeoBon, Biodiscovery, and the CBD Secretariat. As part one of the 24th meeting of SBSTA, we initiate a scientific and technical review of the goals and targets of the post-2020 Global Biodiversity Framework on the basis of the document 24.3 up to Rep 1, which includes a scientific review of goals and targets. We also discuss the monitoring framework under this agenda item, And I would like to mention that there are linkages between the scientific information and the monitoring framework. In particular, the science builds a case for the importance of high quality and timely monitoring. So I take the opportunity to encourage all of you to join the webinar on next Thursday, which will be specifically discussing the monitoring framework. During Substack, a contact group was established for the scientific and technical review of goals and targets in the updated zero draft of the Post2020 framework. I would like to remind participants of some of the discussions that from that contact group, which are relevant for the discussion today. A few items that were brought by some parties were the need for tangible goals, the importance of linking the goals, targets, and the monitoring framework in order to streamline the framework, possible improved alignment with the key transitions in the GBO5, the importance of defining the ambition of the framework and ensuring that the ambition is supported by sufficient scientific and technical information, how the ambition of the goals and targets relate to national actions or targets and to the available scientific information and planetary boundaries, the need for all three levels of biodiversity, genetic, species, and ecosystems, as well as objectives like Objective 2 on sustainable use and Objective 3 on access and benefit sharing. All these to be reflected across the post-2020 framework. Capturing of direct and indirect drivers of biodiversity loss, for example, climate change and those identified by the IPBES in framework. And finally, I would like to mention that this discussion highlighted that post-2020 by the global biodiversity frameworks needs to be rooted in science. At the time of the Substat 24 Part 1, there were still some gaps in terms of the science available, and parties note the need for scientific advice that could be used to inform the deliberation on the post-2020 framework, including quantitative elements of the goals and targets and the monitoring framework. I believe that the information paper discussed today, combined by the Biodiscovery Program of Future Air and the Secretariat of GeoBond, to provide an updated scientific synthesis and assessment base on the first draft on post-2020 framework will be particularly valuable for parties to read in preparation for such a discussion. I will hand over in a minute for representatives of this paper to present the findings, but from my perspective, I would like to share a few thoughts. Firstly, the need for ambitious goals and target setting and action for transformative change is clear. This is important as we go to Geneva, as parties need to remember that without a strong framework which is based on science, there will be irreversible consequences. This is very serious. Secondly, ensuring a clear link between the framework and national target setting and implementation is essential. This is a key message not only for the post-2020 and for the working group on post-2020, but also for Substat and for SDI, which will be considering monitoring, capacity building, technology, implementation, review, financing, and other related issues. And thirdly, the goals and targets are highly interlinked. And thus, the framework cannot be seen or negotiated as a series of silos. I hope that this webinar is useful for all, in particular for parties and observers participating at Geneva meetings in next March. Now, I would like to invite representatives from GeoBond and Biodiscovery to present the findings of this paper. And thank you very much and good luck.
Thank you so much for your kind wishes, Mr. Substa Chair. Hi everybody, good time of the day wherever you are. I am Alexander Rankovic. I'm a lecturer at the Paris Institute of Political Studies and one of the happy authors of the report that we'll be presenting today. So the report is titled Transformative Actions on All Drivers of Biodiversity Loss are Urgently Required to Achieve the Global Goals by 2050. And as was mentioned, the report is available as an information document for the Geneva meetings. Next slide, please. So thanks a lot to Jyoti, Matur Philip, and Ezequiel Benitez for their introductory words. I will first start by saying a few words on the genesis of the report and how we work together. While the report has more than 50 authors, today you will mostly hear from the people on this slide, from the organizing committee of the work. So briefly to introduce the team, and you will see them in a minute. On the side of Biodiscovery, there's Paul Ledley, Cornelia Krug, Lynn Shannon, David Obura. And on the side of Giobo and Andrew Gonzalez, Maria Cecilia Londonio Murcia, Adriana Radulovici, and Katie Millet. Next slide, please. So the genesis of the report, well, it started really from two observations made over the last year. First, as was mentioned during the part one of Substat 24, there was a visible need for additional scientific advice on several aspects of the post-2020 global biodiversity framework. And for example, on the question of how the 2030 action targets are linked to 2050 goals. The second observation was that because of the pandemic, we are now nearly 3 years after the release of the IPBES global assessment. And so there was also probably a need to provide a synthesis of the latest scientific publications to inform the post-2020 process. One problem in this context is that the most, I would say now, natural body or idea of a body to produce such an assessment would be IPBES, but because of its own procedural constraints, it seemed quite impractical to organize a rapid assessment to fill this gap. And so starting last September and between September and December, the scientific community through the secretariats of Biodiscovery, Future Earth, and GeoBon proactively organized itself to propose this collective synthesis of the latest available scientific knowledge on the level and type of ambition that is necessary to achieve global biodiversity goals by in 2050. Next slide, please. So on the process and how we worked, the organizing committee invited scientific experts working on different realms and dimensions of biodiversity and from diverse geographical backgrounds. And in total, the report was built by 52 contributors from 23 countries. And the selection was focused, but not limited to, focused on experts who were already involved with GeoBon, Biodiscovery, or IPBES. The collective work was iterative. There were initial themes proposed by the organizing committee that were discussed during different online workshops that we started in November, and then gradually refined. And subgroups were subgroups of authors worked on different aspects of the literature that was published since 2019. And on top of that, we also invited 4 external experts, external to the group, to review the document. On page 7 and 8 of the document, you can find a full list of contributors and their affiliations. Next slide, please. When we informed the Secretariat of the CBD, they kindly accepted to actually make this work available as an information document, and would like to thank them again for this, as well as for helping us set up this webinar, and also for very useful remarks both by the Secretariat and the Post2020 co-chairs that provided us useful feedback on the clarity and consistency of the text. And thank you again for this. Next slide, please. I was pushing the button on my own computer. Thanks. So before we present you the main findings, I would just like to say a few words on the objectives and framework of the report. The work had three main objectives. First of all, to show how the 21 action targets for 2030 that are proposed in the current draft of the GBF are related to outcomes for biodiversity as they are set out in the goals and milestones for 2050. Everybody in the authors group understood the importance of all of the 4 2050 goals and their milestones, but we had to focus mostly on goal A and its milestones because mostly of time constraints. The second objective was to synthesize the evidence base that is out there, the latest one, to help set the ambition that is needed to address the drivers of biodiversity loss in order to meet the 2030 milestones and hopefully which would lead us to attaining the 2050 goals. And lastly, the objective was to assess and show the importance of using indicators that can be used to track progress towards goals and targets, but also enable the attribution of biodiversity change to different drivers, as well as inform strategic planning of actions that are needed to achieve the GBF outcomes, and so that are set in the goals. Next slide, please. And so the framework, and you will hear that in the presentation, is really rooted into the conceptual framework of IPBES. So the focus was both on direct and indirect drivers, their impacts on biodiversity and ecosystems, and actions that reduce the negative impacts of these drivers. And on this graph, you can see a mapping of the GBF goals and targets in the different parts of the conceptual framework of IPBES. And with that, I would like to pass the floor to Paul to start presenting you the findings. Paul, the floor is yours.
All right, thank you very much, Alexander. So one of the first things that we did in our analysis was to try and respond to very legitimate questions that were being asked at the Substa in it last year, and also in a number of other fora, and particularly questions about what is the relationship between the different targets and the milestones, as Alexander and Hesikki have already said. But specifically, we wanted to look at the quantitative contributions, the relative contributions of each one of these targets to the different milestones. In particular, a number of parties and stakeholders have been wondering, do we need this much complexity? Can't we reduce the complexity somehow? Aren't there some actions that we could take in these targets that are much more important than others? And we could focus more on those, or couldn't we make a one-to-one relationship between targets and milestones and goals? And our analysis, what we've tried to do then is to look at how the different targets feed into the different components of the milestones, so the different dimensions of biodiversity, ecosystem, species, and genetic diversity, and then to goal A. And what we've done here is to develop a flow diagram. So if you start on the left of this diagram, you see the indirect drivers of biodiversity change that then arrows show are underlying the direct drivers of biodiversity change and the different targets that are meant to act on those direct drivers, and then how those the actions in those different targets are then feeding into the 2030 milestones. And what you can see, especially in this relationship between the direct drivers and the milestones, are these connections, and these connections show two things. How are each one of these targets connected to each one of the milestones? But it also shows quantitatively the relative contribution of each one of those targets to those different dimensions of biodiversity. And so what I want to do is walk through this analysis that was led by David Obura and show you where how this analysis was done and what it tells us. So next slide, please. So to simplify this, I want to start with a very sort of schematic diagram. So we have the three different components of the milestones corresponding to these three different dimensions of biodiversity. Next. And feeding into those milestones, what we did was to try and analyze how each target would contribute to each one of those milestones, starting with those that are the direct drivers, or those that appeared first, and then moving out to the indirect drivers, tools, and solutions. And so this gives you just an overall picture of how we built up this analysis. Next slide, please. And so in order to provide a quantitative backing for this analysis, and this goes to the third finding in the executive summary of our report, we started by looking at how the direct drivers of biodiversity affect the different dimensions of biodiversity. And that's this figure that you see on the upper left-hand side of this slide. So you see the relative contributions of climate change, direct exploitation, invasive alien species, land and sea use change, and pollution to changes in genetic diversity, changes in species, and changes in ecosystems. And the first thing that we see there is that all five of these main direct drivers of biodiversity loss, each one of them has a relatively large contribution to biodiversity loss. What we've done is we've transformed that information into contributions. So targets are going to be acting on these different drivers. And so next, please. So the table that you see below that is the attribution of how each one of these targets then is going to act on those direct drivers. And by building up this table, we could actually then build a quantitative relationship between each one of the targets and their contribution to the three different components of the milestones. Next slide, please. One of the most important things that's come out of this analysis is that every one of those targets acting on the direct drivers, and you see those here in this bar diagram, every single one of those has a relatively important contribution to each of the dimensions of biodiversity. In this particular case, no one individual target contributes more than about 12% of the total change or the total contribution in achieving a milestone. And in this particular case, we're looking at the ecosystem milestone. So what does that mean in terms of these big questions that are being asked? Well, first of all, we're providing a roadmap of how the different targets are actually contributing to achieving each one of the milestones. It also answers the question, can we reduce the complexity? And unfortunately, the answer is no, the way that the global biodiversity framework is set up actually corresponds scientifically to what we know about the complex relationships between direct drivers and outcomes for biodiversity, how actions are going to operate on those direct drivers. And it also shows that there is no one particular small group of actions in these targets that really would have a major influence, and therefore we could really focus on them rather than others. Next slide, please. And we've not just done this in a sort of very broad perspective. We've also tried to provide very specific examples of how multiple actions are required to halt biodiversity loss and actually turn biodiversity loss around. One of these illustrated in the executive summary are the variety of actions that are needed to avoid extinctions here in bird species. So over the last decade and a half, probably around 25 to 32 bird species have been saved to extinction. And this shows the variety of actions that have been necessary to save them from extinction. And what that analysis shows also is that all of those, in almost all cases, it took somewhere between 4 and 6 actions, broad types of actions to save species from extinction. We've also done this looking at using the example from mammals from this same study that was done, but we've also done it at the ecosystem level for coral reefs and for Amazon tropical forests. And we've also looked at this not at extinction rates, but also looking at actions that have restored species populations of species that were not at the verge of extinction. So if you want to look for some very specific examples of why these broad set of actions need to be taken, you can look at these specific examples. Next slide, please. And next, please. So in addition to looking at these relationships between the direct drivers and the milestones, we've also more broadly tried to illustrate that there are multiple interactions between indirect drivers and the direct drivers. Now, we've not done a systematic quantitative analysis of that, and I'll be presenting that just in a second, of how these indirect drivers are also important to address. So to summarize, in response to those legitimate questions that are being raised, it is important that we act on all of these direct drivers and that the full set of targets are necessary. They all contribute in an important way to achieving each one of the milestones, and there's no single small set of these targets that have a really big influence and that we can focus on in particular in order to achieve the milestones. So it really means needing to treat all of the targets together. Next slide, please. So what I'd like to do, that analysis was primarily focusing on the relationships between the targets that are acting on direct drivers and the milestones. I want to shift now to talking about the indirect drivers and the relationship to achieving the milestones and 2050 goals. And this analysis suggests that transformative change is absolutely essential to achieve ambitious 2030 milestones and 2050 goals. And so what's transformative change? Transformative change was really put in the forefront in the IPBES 2019 global assessment. And broadly what it means is we need quick sweeping changes in all of the indirect drivers of biodiversity loss. And specifically, what does that mean? And I've just put a couple of examples here. It means we need to move very quickly towards sustainable production and consumption, especially for food systems. It means that we need deep cuts in subsidies that are harmful for biodiversity. It means, as Hesikio said, there's an urgent need for mainstreaming of biodiversity, both in the public, in government, and in business, and so forth. Specifically, in the context of the global biodiversity framework, It means that you need to have high ambition and, if at all possible, quantitative objectives for targets 9 through 21. So what we've done to illustrate this is to take two pieces of evidence. One are recent trends in indirect drivers, direct drivers, and their impacts on biodiversity, primarily coming from the IPBES Global Assessment and the Global Biodiversity Outlook 5, but also many recent publications, and combine that with a very new synthesis of global sustainability scenarios that have only become very recently available over the past year or two. And I want to show you what that synthesis of scenarios shows. Next slide, please. So what we've done is to divide these different scenario studies into three main categories, or three types. One of them we've called continued trends, which you can think of as business as usual. We just keep doing what we've been doing all along. One are scenarios that are really focusing on what would happen if we had really high ambition and achieved goals primarily for conservation and restoration. And the final set of scenarios are looking at transformative change. So what happens if we really are looking at changing systemically society and these indirect impacts on biodiversity. Now, the colors in this table here indicate achievement of ambitious targets. So the first set of targets are around protected areas. The second set of targets are grouped around restoration, spatial planning, and species management. And a third grouping, this third line, are around treating the rest of the direct drivers, and especially looking at indirect drivers like sustainable production and consumption, mainstreaming, and subsidies. So in the first scenario type, the continued trends, it's been assumed that a high percentage of area is protected on land and sea, but there is only modest progress, as there has been in the past, on them being effective and representative. That there's modest progress, that's yellow, the color, in restoration, spatial planning, and species management. And in the pink color, actually, as in the past, relatively weak or no progress on things like pollution, control of invasive species, and especially aspects like sustainable production and consumption and subsidies. The second scenario type assumes that protected areas not only have high coverage, but they're also effective and representative. A very good job has been done on achieving ambitious goals for restoration, spatial planning, and species management, but we still haven't made much progress on those direct drivers of biodiversity loss. And transformative change assumes that we're making great progress achieving all of the ambitious targets that we've set across all 21 targets. Next slide, please. And so what then is the outcome for biodiversity based on our understanding of what's happened in the recent past and what models and scenarios tell us? Essentially, they tell us that in continued trends, even if there's a 30% of protected areas, if they're not effective and representative, there's actually relatively little progress towards any of the ambitious milestones for ecosystem, species, and genetic diversity. All of the cells in that column for continued trends indicate that we continue on declines in biodiversity across all those three dimensions of biodiversity. For the conservation and restoration scenario, where we've made really good progress on protected areas, restoration, species management, it indicates that actually we can slow, all our scenarios suggest that you can actually slow substantially biodiversity loss, especially in natural ecosystems, but you can't halt it, and you're certainly not on a pathway to bend the curve, that is to actually then restore biodiversity by 2030. And it's only if you actually do the things that are transformative change, changing agriculture, changing fisheries, changing our diets, mainstreaming, all of those things that are associated with transformative change. It's only if you do that that you can actually halt biodiversity loss and get to bending the curve, or what's been called a nature positive future. So to summarize, in terms of, especially in terms of the global biodiversity framework, that means a very narrow focus on the targets 1 through 4 can have very positive effects and are absolutely essential for achieving the ambitious 2030 milestones, but they're largely insufficient. If we really want to halt biodiversity loss and bend the curve, we need to treat those indirect drivers of biodiversity loss. And with that, I'd like to ask Katie to talk about the next findings.
Thanks, Paul.
Thank you.
So I'll be talking about findings 4, 5, and 6. So finding 4 of our report indicates that the implementation at the international, national, and local levels will be a primary determinant of the framework success. This is because drivers of biodiversity loss operate at and across several spatial scales to affect biodiversity. So while the numerical targets defined at the national levels are key, we must not also forget that the local level scale is also important. Because of this, we believe that there is a need for flexibility in the framework to adapt the implementation of the targets. This flexibility should allow for the integration of data and new information gathered through assessments of biodiversity and drivers at all spatial scales. There is also a need to assess how actions conducted at the local, national, regional, and the sub-regional levels are contributing to the achievement of the global targets and goals. And lastly, regular evaluation of actions and outcomes should be conducted. The results of any action that takes place should be shared and analyzed with other parties and stakeholders, and if it's successful, perhaps iterated and adapted to other actors where appropriate. Next slide, please. The next finding that we discuss in the assessment is about managed and natural ecosystems. So reversing biodiversity loss will require addressing threats to biodiversity in both natural and managed ecosystems and the interconnections between them. Biodiversity exists in a mosaic of habitats that we define based on the degree of human use, interference, and exploitation. Natural ecosystems like forests, savannas, mountain slopes, and oceans, numbers 1, 2, 3, and 4, in this IPCC-IPBES joint workshop report from 2021, as well as managed ecosystems, which include rangelands, farms, towns, and modified coasts, indicated by A, B, and C here. They both host different variety of species, and they also respond differently to human drivers. The proximity and interconnections between natural managed ecosystems can influence their respective dimensions of biodiversity within their areas. In addition, indigenous peoples and local communities and people with long history of integration with nature can make large contributions to conserving nature, particularly in managed ecosystems. For these reasons, the distinction between natural and managed ecosystems needs to be better reflected in the framework. We suggest extending milestone 8.1 to include managed ecosystems and their integrity. Next slide, please. And finding 6 has to do with the interlinkages between all dimensions of biodiversity. So all dimensions of biodiversity are interlinked, and they have interlinked responses to human drivers. Dimensions of biodiversity, as most of us know by now, include genes, species, populations, communities, and all the way up to ecosystems. Any action on a driver on biodiversity loss with the aim of improving one dimension of biodiversity will have ripple effects across all other dimensions of biodiversity. For example, an action that aims to maintain species population will contribute to the maintenance of genetic diversity and also reduce species extinction rates, while at the same time providing ecosystems with greater resistance to disease outbreaks and pests, and also provide more resilient ecosystem services. The interlinkages between all dimensions of biodiversity underlie the many-many relationship that Paul was showing between any one target and any one goal in the milestone. Our knowledge of this interlinkages between biodiversity dimensions should guide priorities for conservation and help with the formulation of the quantitative elements of the framework's targets, milestones, and goals. So now I'll pass the floor over to Maria, who will carry on with the next findings.
Thank you, Katie. Okay, so finding 7, immediately and sustained action to ensure recovery. So, okay, biodiversity takes time to respond to any driver or conservation action. This is given because different ecological and evolutionary processes underpin the response to biodiversity. Biodiversity recovery lags depends on the driver, the conservation action implemented, and the ecosystem. Several scientific publications give us clues of the time and shortfalls of biodiversity during recovery. In the bar graph, we can see the lags in species diversity and abundance. In the white bars, the times needed for the recovery, and in green, the amount of lag, which should be understood as a shortfall in biodiversity or ecosystem function that accumulates during the time of recovery. This paper shows that the species abundance presents a deficit or a shortfall between 46 and 51% during the time of recovery. And the time of recovery may take 5 to 30 years depending on the driver. So scientific information about time and shortfall of the lags could be integrated into the GBF milestones, milestones that track the path to the recovery. Time lags can be shorter if action is implemented immediately to reduce the effects of drivers of biodiversity loss. And it's also important to note that scientific studies have shown that recovery slows down with time post-disturbance, meaning that long-lasting sustained action is needed to accomplish biodiversity recovery. Next slide, please. Okay, finding 8 talks about the coordination across scales. Now, biodiversity and ecological process are represented differently across the globe. And also drivers and their effects on biodiversity vary across spatial and temporal scales. In recent years, scientific information have shown how the source of a driver may be distant from the location of its impact, and this phenomenon is called as telecoupling and is of most importance to reduce drivers of change. Distance and connected impacts of drivers must be acknowledged to achieve the GBF goals. In that sense, mechanisms that account for global biodiversity patterns, responsibility of drivers and response capacities will be needed to ensure fair sharing of conservation burden among parties. Scientific information on biodiversity, ecosystem, and driver distribution exists. See, for example, the figure in this slide showing where biodiversity is affected by consumption in other places. Also, another recent analysis show that 31% of the global effort needed to reduce mammals, birds, and amphibian extinctions focus on just 5 countries, while 88 countries represent 1% of the effort needed. Each country may need to prioritize the set of targets and actions that are more critical for their contribution to the achievement of the global goals. The type and amount of action that different parties need to perform varies with the biodiversity they host, as well as the remote biodiversity that their actions affect. Targets should be designed according to accounting mechanisms and estimated national responsibility. Additional information on trade or development could be used in the accounting mechanism. Conserving biodiversity and nature contributions to people in a globalized economy will require to strengthen and focus more the international collaboration efforts in mitigating drivers of and reversing biodiversity loss. Next slide, please. Okay, and the last finding is investing in monitoring. Now, indicators are needed not only to assess progress towards the goals and targets, but also to inform strategic planning of actions to most efficiently and effectively achieve outcomes. Currently, biodiversity indicators achieve trend detection, but trends are rarely attributed to possible drivers. A detection and attribution framework for biodiversity is needed to establish where and to what extent drivers are causing biodiversity change. Detection and attribution is needed to plan and prioritize intervention. In the figure, you can see in the external blue cycle how the current headline indicators work for indicating progress towards the goals. But in the center of the figure, in green and gray arrows, we show how different indicator sets have to be able to guide action. The scientific information also shows that leading indicators, meaning those indicators that respond to future situations, are much needed in order to guide conservation and sustainable management. So in the circle of this figure, you can see the detection and attribution systems that we are proposing for complementing the GBF monitoring framework. Data on direct and indirect drivers from complementary institutions to the CBD, such as the FAO or the EATA, and data used to report indicators for the SDGs could be incorporated with the GBF monitoring framework, aiding in the establishment of that detection and attribution system. Finally, because data and data processing underpin the production of indicators, substantial investment in monitoring is needed for sustaining data collection and biodiversity information infrastructures, which should be seen as essential elements of the overall capacity required to assess progress and guide action to achieving the goals. Thank you, and the next speaker is Andy.
Thank you, Maria. So allow me now to summarize these findings with the 8 key messages that we provide in this information document. These key messages that you see arrayed around the circle here are a distillation of the information in the executive summary. So to key message 1, which was on transformative change, the body of evidence our experts reviewed showed that halting biodiversity loss by 2030 and reversing biodiversity loss by 2050 is going to require transformative change in all sectors of society. Achieving ambitious targets for conservation will require expanding investing in protected areas, in species management plans and restoration. These are vital elements to an integrated plan to achieving the GBF. But it's only through action on indirect drivers that we're going to achieve nature positive outcomes for biodiversity. And if we do that and sustain that, then we can expect to bend the curve by mid-century. Key message 2 was act on all drivers. We also found that achieving ambitious objectives for biodiversity and goal A is going to require a comprehensive set of actions to reduce all the direct threats to biodiversity, from land and sea change, to climate change, direct exploitation of organisms, chemical pollution in all its forms, and acting on invasive alien species. But crucial to our message is the interaction among these drivers. These interactions vary geographically. They are articulated in space very differently from one region to another. So we're going to have to prioritize our actions on these drivers from place to place, and do so in a way that ensures that national contributions achieve global outcomes. We're going to have to be smart about how we prioritize our actions on these direct drivers. Key message 3 is about acting across levels. Global targets of the GBF are an important template for action, but it's how these targets are implemented and how actions are coordinated across local, national, international levels that will determine the success in achieving our objectives for biodiversity. So we have to not only be coordinating our action, but we have to be adapting it and iterating it over time and across levels if we're going to achieve positive outcomes. Key message 4 is about making sure that we address biodiversity change in managed and natural ecosystems. Reversing biodiversity loss will require addressing threats to biodiversity in both those contexts, but in particular the interconnections between them, right? Thinking about the connectivity between managed and natural ecosystems. That is something that we can act on, and we know how to do that. Both natural and managed ecosystems differ substantially in the biodiversity that are retained there, in the suite of ecosystem functions and the supply of contributions that people receive from ecosystems in those places. So our targets have to be commensurate with those differences. We need to align indicators and monitoring requirements with those differences, encompass that and align our actions in consequence. Key message 5 is about acting on all dimensions of biodiversity, from genetic all the way up to ecosystem and on up to the biome. All dimensions show interlinked responses to human drivers. Our efforts to mitigate the effects of drivers on one dimension, such as genetic diversity, for example, will result in positive outcomes on other dimensions, such as population abundances and extinction rates. That's a good news. That's an important conclusion from this document. It's the knowledge of these interlinked relationships between the dimensions of biodiversity that can be used to guide and prioritize our actions. Message 6 is about time lags. There's good evidence that while some dimensions of biodiversity recover rapidly following conservation action, many show long-lasting patterns of recovery following our efforts to mitigate the effects of drivers. Ambitious action on drivers is needed as soon as possible and must be sustained if we're going to put biodiversity on a trend to recovery by mid-century. Key message 7 was about distant impacts. The global nature of our economy means that biodiversity loss may be driven by demand in faraway places, often in other continents. So international collaboration could focus on how to address these geographic disparities and the impacts that they have on ecosystems and nature's contributions to people. And last and certainly not least, key message 8 about monitoring. It's clear that successful implementation of the GBF will require substantial investment in our capacity to monitor biodiversity. But a key message from this report is that we must monitor the drivers. We must monitor the drivers in order to guide our actions to bend the curve for biodiversity. This is going to take a global monitoring system that fills important taxonomic and spatial gaps in our understanding of how biodiversity is changing. And there is a need to ensure the supply and access to data that underpin the effective use of indicators that not only track our progress, but also guide proactive action needed to implement the GBF at local, national, and international levels. So this brings us to the end of our presentation. I want to thank the CBD and the Secretary of the CBD for giving us this forum, and we're looking forward to addressing your questions in due course. Thank you very much.
Thank you. So before we start with the Q&A, I just want to give a quick reminder to anyone who is new to the or has used the GoTo system, and for anyone who has not. Unfortunately, the way that GoTo works is that we are not really easily able to hand over the floor. We set the presenters in advance, and so if you have questions, please enter them in the chat, and we will do our best to tackle those as they come in. Thank you. So in terms of kicking the discussion off, I think that this question may be best for Paul, and this is really, how do you analyze which drivers are going to have the biggest impacts and what those impacts are, so that you can determine how to focus in on individual drivers? Obviously, the message is to focus on everything, but how do you know how much to focus on different things, and how do you do sort of a cost-benefit analysis in order to determine this? Thanks.
So our analysis only looked at the overall contribution of the different drivers to the different milestones based on the best assessment. And I think that that's relatively robust. But the question is a little bit different, and that is, if you change a driver by so much, how much influence will you have on a particular milestone? And that analysis, actually, we've not done. Now, we can take some of the global scenarios that have been done to try and look at that. And you can go through those scenarios and ask the question, how much change do we need to make? So I would just take one example. In some of the scenarios that are looking at transformative change, they've looked at how much do you need to change diet in order to get to positive outcomes. So one of the key findings is not everybody globally has to be vegetarian, but there has to be convergence on what we call sustainable or healthy diets. And in many cases, they're using the Eat Lancet diet. So that's with reducing overconsumption meat and overconsumption of calories. And if you don't do that, then you really can't very easily get to positive outcomes for biodiversity. So we can do that on a few of the components, but it's very difficult, for example, to answer the question, is reducing nutrient pollution from excess nutrient pollution from fertilizers from 30% or 40% or 50%, how much X% is that going to contribute to each one of those milestones? Unfortunately, we don't have the scientific evidence to back that up. And that's going to be very difficult for the scientific community to provide.
Thank you. So I'm going to hand the next question to Maria to start off, but I think others may want to come in on this question. And it was something that came up strongly in the morning as well, is how, sort of two questions here. How do you strengthen the policy, the science policy interface at both the global level and at the national level? So how do you bring this down to the national level? And I think that this brings a follow-up question that I know others are thinking, is how do we then also nationalize the GBF in order for countries to be able to make decisions on how they implement the GBF and what is sort of the contribution that they need to make towards the GBF in order for the overall global vision to be achieved. So I'll hand over to you, Maria, to start off.
Okay, thank you. So my first response on how to work from countries to the global level, let's say how countries prioritize their actions. Obviously, each country has its national agenda, but if we really want to think on global targets, we need to think, countries need to think their national agenda in what their actions meant for other countries also. So this think of the telecoupling, you know, the interactions between what you do in one country and how that affects others. We really need to think about the country's actions and how they can fulfill their agenda, but at the same time support the achievement of global goals. So that, I think, is one of the first things that the parties need to have in mind after reading these key messages of this info document, and then go to the negotiation. That may be the first one. And then, well, the science between, let's say, the adding of the target to really get the fulfillment of the target. I think that is something that just Paul was mentioning, that might be hard to do really in the quantification for some targets, but I guess we do have a lot of scientific information that give us some ranges where targets could be more specified. So I don't know if okay, the working and the political level, maybe that was the other question, the first one.
First part of this question was strengthening the science policy interface at the national level. And I think probably Andy may want to come in on this question as well.
Sorry, trying to find the volume button. Yes, the experience that I've had is that the science that we showed today has a regional version. That the flow diagram that David Oburo put together and Paul presented actually has region-specific, country-specific articulations. And so we often have access to data and models that allow us to assess the relative contribution of those various drivers, both indirect and direct, on specific biodiversity outcomes. And from my own personal experience working in Canada and working in a province like Quebec, is that we have close collaborations with ministries, with research synthesis centers, NGOs. And so what we do is we're articulating the science that we presented today at a downscale national or subnational level. And then we can iterate the conservation targets towards those through that collaboration. So it's taking that information that we shared today and realizing it at the appropriate scale. And then that can be carried forward.
Thank you. So there's a couple of questions that are a little bit similar, so I think I'm going to group them together. And I think, Paul, this really is for you, and it's in terms of the drivers that will impact the different goals and targets, or primarily the goals. Two things. One is someone is mentioning how population growth could have a substantial impact on a number of these, and so how could that be taken into account given that it's changing constantly, or it is creating constant change. And similarly, somebody asked, you know, the current situation that we are in, there's been a massive upheaval based on the pandemic, and so how valid is the research on the drivers, given the fact that things may change moving forward? Thanks.
So the first question, so all the scenarios that we've looked at assume sort of middle of the road population growth. And it's obvious that if you have lower population growth that's being currently projected by UNDP and others, that would really help things. And if you have higher population growth, if you're at the high end of the spectrum, that is going to make getting to positive outcomes for biodiversity far more difficult, because of the demands it's going to put on not just the food systems, but also broadly consumption and production. So it's key. It's not incorporated in any of the targets specifically, so it does have to be kept in mind that that's really important. I think, well, one of the things to keep in mind that is really important is that most of these scenarios show that there are really big differences that you get from changes in sustainable production and consumption. And in many ways, those differences are larger than the differences you get in the different projected population growth rates. So you get a larger contribution from going to sustainable production and consumption per person than you do looking at the range of different population sizes. To answer the second part of that, sorry, Jillian, what was that again? The second part was on
how the world is changing because of the pandemic.
So that's a really good question. None of the scenarios that we look at have abrupt changes in them. It's considered to be one of the problems with the way that we build scenarios. We're well aware of that. And obviously, they're not taking into account kind of things that we're going through now. If you look across the broad sweep of what's happened over the last many decades, last several tens of decades, despite big bumps like the crash of 2008, the overall trend is actually fairly constant. And this may actually turn out to be more of a 2-year blip in a constant trend than what we see it now as in the middle of it, where it looks like a major shift in the way humanity operates.
Thank you. So the next question, I'm going to try to pull it apart a little bit and ask Katie. And this is, again, a question that's somewhat similar to this morning, is how were abiotic components included in the sort of scope of ecosystems that you looked at? And you know, there is also a link between the living components, the abiotic, and the climate components, and how was this brought in any way? Thanks.
Yeah, the abiotic components they're very critical for the functioning of ecosystems. We didn't factor them explicitly, but as we do know in what happens when agricultural systems are in place, they can really deplete resources and nutrients from the soils, and these take long times to recover. And we showed this, I believe, in one of the recovery debt scenarios, where soils that are affected by agriculture take like up to decades, sometimes up to hundreds of years to recover. So abiotic systems were not exclusively considered abiotic factors, but they are obviously a very important aspect of everything.
Thank you. And I think this question is also probably for you, or you could provide some answer, which is, how did you look specifically at different vulnerable ecosystems? The person is giving the example of islands, but obviously there's many different vulnerable ecosystems, and how were these broken out?
Yeah, I think maybe Paula might be better at this question, because there's that large box that we talk about, coral reefs, and I mean, these are very particular types of ecosystems, and they do include islands and those types of things as well that are very susceptible to invasive species. But Paul, do you want to take that question?
Sure. In section 1 of the analysis, we don't look at all of the different ecosystems, but we do have a section on ecosystems and point out some of the ecosystems that are more sensitive to others. And in particular, we point out the importance of climate change and the fact that climate change is perhaps not sufficiently well accounted for in the global biodiversity framework as it's currently formulated. Clearly, things like coral reefs, Arctic ecosystems, and island ecosystems are going to be very heavily impacted by climate change, even at 1.5 degrees, and certainly if we go well beyond 2 degrees. And that really needs to be taken into account when we're thinking about the ability to halt biodiversity loss and turn it around. We haven't gone through a specific analysis of all vulnerable ecosystems, but we have pointed out some of the important ones.
Thank you. So now I'm going to come back to the issue that you sort of touched on. I think it was the first question, and I'll go to Andy and then maybe Paul. Someone is again asking on this prioritization of action and linking it really to the prioritization of action at the local level. And so how do you use geospatial information or local information in order to really prioritize different actions at different levels, depending on the need and the ability?
Great, that's an excellent question. The first thing to say is that we can do this. So we have spatial prioritization tools that are freely available and are understood and do give you the kinds of spatial prioritizations that people are looking for. So let me give you a very concrete example. Right now in Canada, we're trying to prioritize a set of actions for achieving goals for connectivity. So how to reconnect heavily fragmented forest ecosystems, wetlands, and in many places we're down to the scale of a few hectares of very small remnant ecosystems. And so in that instance, what we do is we're working with geospatial information, so that's satellite information, that's observations on the ground, and we're working with NGOs, municipalities, local scientists, and we build the spatial picture of the landscape. And that allows us to give us an input layer into these prioritization tools. Then we can grab data from the Global Biodiversity Information Facility, from national and regional data repositories, information from our regional climate models, and projections of land use change. And we put that into what's called a multi-criteria prioritization analysis. That's a long word for saying that something finds an outcome, an optimal solution when you're trying to optimize for a bunch of things at the same time. And it offers different scenarios based on what our targets are. So if our target is 20% restoration of connectivity or 30% restoration of connectivity, different areas of the landscape start to light up. And so that gives you very specific locations to prioritize action. And so now we've gone through this first phase, and now we're working with NGOs, with municipalities, even quite small towns, working in a coherent, coordinated fashion to achieve that outcome for an area the size, well, it's an ecoregion, so it's an area the size of Switzerland, actually, of the St. Lawrence lowlands. So this is doable. The calculations don't take forever. The data can be gathered if we work in partnerships. My opinion is that we need to do this and start coordinating these actions across ecoregions if we're going to start seeing these scaling up of outcomes.
Okay, so I think now I'm going to take this question for Paul. And to me, the question relates again to sort of the discussion of managed and natural ecosystems that comes up in the report. The question, as it's phrased, is asking how the GBF should address specific biodiversity loss land use drivers like agriculture, forestry, and fisheries, and also urban areas. But I think this does relate a little bit to the overall approach to tackling managed and natural ecosystems versus also trying to tackle things like pollution in the context of media. So, Paul.
So one of the things that we say very clearly in the executive summary and also in one of the sections is it's really important, and that's already been said, to treat this difference between natural systems and managed ecosystems and this gradient in between. One of the things, very specific things that we've suggested, and that was already raised, I think, by Katie, is that milestone A.1 does not include an objective for integrity of managed ecosystems, even though the 2050 goal does. And given the importance of biodiversity in managed ecosystems, it's probably very important to include this in milestone A1. The second thing is that when you're measuring things like the integrity of managed systems or working landscapes or working seascapes where you have a mix of managed and natural systems, it's really important to have appropriate indicators for that. And currently, one of the headline indicators for ecosystem integrity is primarily designed for integrity of natural ecosystems, and it's actually fairly poorly adapted to managed ecosystems. And there are now a few operational ideas for indicators of the integrity of managed ecosystems that actually could be used to actually track progress towards a milestone that would be focusing on biodiversity in managed ecosystems. So that's just one very explicit way in which it would be good to handle the relationship between managed and natural ecosystems.
Thank you. I think that we are reaching the sort of end of this technical session, and I would again, from the Secretariat side, like to thank everyone who's participated in the webinar today, and thank also all of the speakers. And now for some concluding remarks, I'm going to hand over to one of the co-chairs of the Open-Ended Working Group, Basil.
Thank you. Thank you very much. And first, let me start by thanking Giobon and Synchronicity. But beyond you, the many people, the 45 or 50 people that have donated time, we all know that you didn't get a contract to do that. You're doing that voluntarily over a Christmas period at odd time. So a big thank you coming from Francis and myself. Now, turning the next few remarks to the whole group assembled here. Let's start from where we were in 2018. We collectively decided to guide the drafting of the GBS by 14 principles. One of those principles is to be science-driven. And we started with the EBES assessment, and today we're getting an update from a group of scientists. So the science are giving us some advice, and this is very important and welcome. The challenge is going to be now, how are we going to be reflecting that advice into the GBF? We will be getting together soon in March in Geneva and start a negotiation, and we will get many different inputs into our work. I'm getting every day comments from one organization and the other, and all that is very important. The challenge we will have is how will you factor all of this into a coherent whole? How will we communicate that to decision makers, to the people that ultimately are approving our mandate? Yes, in fact, when we looked at what we heard today, and I was exchanging parallelly with some of you on chat, this is common sense for many scientists. This is things that we've heard one way or the other through the other dimension. I think the value of the piece of work that is put in front of us is how it is bringing it all together and bringing in the rationale. So it's up to us to use that bit of a gem that we got in front of us. This is not an easy message that we're given. This is actually quite a difficult message. This is not about just doing one thing. It is about doing it all. And it is about trying to convince people that the efforts needed to do that large-scale transformation change, and some of you know that I'm not very keen on using that word, but let's call it large change, is needed and is something that will be positive, but require a significant investment. It is going to be a challenge because it's a lot easier to speak to what we can control, and most of us in environment ministries, we have good connection to protected area levers, and that's something we know how to do. Reaching out to our colleagues in the agriculture ministries and administration and to the agri-food industry in general is a lot more harder. But let's not shy away from that. That's going to be important. Now let's talk about what is coming next. So I've talked a little bit about the negotiation process. I've watched with a lot of interest the question as they were coming in, and it's very interesting to see how people are focusing their questions, and Gillian did a good job in trying to summarize those and direct them. But I hope there is a way we can capture that and share that one way or the other in a document. There is a lot more work that needs to be done. I'm sure we would very much welcome advice on numerical aspect of the targets that has been pointed to us in no uncertain way this morning. But that needs to be, we need to think about how we do that. And if I was king, I will be directed the people on this call, Paul and Andrew and company, to continue the work, but I'm not king, and I'm just begging so that they can continue to do some work with us. We need to build some tools to do the kind of scenario that we're going to need. The negotiation of the GBF is not an end, it is a beginning. It is a beginning of an implementation journey, and we're going to need science to be side by side with us. So we're going to need to perhaps reshape that relationship. So let's not do one assessment and we can go back home and do whatever we like to do and come back. We're going to need that interactive back and forth relationship that we started to build today. So once again, thank you for the team. This is very important. This is daunting. This is challenging, but thank you for doing that. It's the ball is perhaps a little bit in our court now to try to see what we're going to do with it. So let's impress those science guys with some impressive GBF. Thank you.
Thank you, Basile.
Thank you.
Thank you.
Thank you very much.
Thank everyone for coming today. And I think with that, we're ready to close the webinar.
Much.
Thanks, Gillian. Thanks, Yoti. Thanks, Ezekiel.
Thanks,
Thank
everyone.
you.
Thanks,
Thank
Basile.
you.
Bye-bye.
Bye, everybody.
Take care.